So let's talk about parallelism for a minute. Maybe this is obvious to everybody who's listening to these videos, but parallelism is an integral part of the kind of technology we need in order to solve our analytical financial system problems. The concept of parallelism is that you can deploy more people, more computers, more processes in parallel to solve larger problems than any one process can take to solve the problem by itself. The issues of problem of waiting for the total time it takes to solve a problem until one single process solves it. Parallelism allows us to break things up into smaller pieces and have those smaller pieces solved simultaneously in many different ways and then bring the results back together. That's a critical part that goes on in our cloud platforms all the time. We use parallelism because we need large bursts of compute capacity in small amounts of time, and no one wants to wait for years for a problem to be solved, or it would take a long time for a search query to be solved by a single computer when you enter the search tool. That process of entering a search term actually gets spawned off and gets solved by many computers, each one just taking an instant to solve their portion of the problem, and then the results are brought together and shown to you. That same process has to happen when we go through these scan processes to do analytical work against transactional financial structured data. That problem though, the last piece of that problem though, is the more concerning or more difficult part. It's bringing the results together at the end that becomes the problem. See, if all I'm looking for, if the problem I'm trying to solve, the query I'm asking, allows it to, you can spread it out on a whole bunch of computers, but the end result is the first computer to find the problem shows me that answer, then I don't have to bring together all the answers, then that's one thing. But when we look at the financial, when we get to balances and positions, those typically are accumulations of more data than just the single transactions that might be found by any single node of the process. That process of consolidating the data means that at some point you have to bring the data back together again in some synchronized point in the process. That can create significant problems for parallelization. If you can determine what the parallel key is, then and your question only fits, it becomes so small because it's looking for a needle in a haystack, then that's one kind of thing. But most of our data, we're looking for patterns that cut across things for how the data is stored. And if this data is stored to solve one question, it typically is not well suited for solving another question. So one of the key processes, as we talk and think about Spark as a technology, it does allow for parallelization. That's where it came from, and it's a great framework for doing parallel processes. The problem's not the parallel processing. The problem is after the shuffle processes, it's bringing the consolidated data back together. That is the more challenging part of our financial analytics.